So I want to just review this idea of something being statistically significant. If we get a result in a study and we say that result is statistically significant, what exactly does that mean? I talked before about the idea that if I have two groups of people and I'm measuring something like their height. So I have some people, I'm measuring their height. I decide that I want to have two groups of people where the height is about equal. One way that I can do that is through random assignment. So I randomly assign people to two different groups. Maybe one of the groups I'm going to give some kind of a treatment to, and the other one is going to get no treatment, or maybe some kind of a placebo, whatever it is I'm studying. Maybe I'm studying how diet affects children as they grow. So at the beginning of the study, I want the groups to be about the same. I want to equalize things. So I randomly assign them to the two groups. And the idea is that through that random assignment, some of the taller people are going to end up in one group, and some of the taller people are going to end up in the other, and some of the shorter people are going to end up in one group, and some of the shorter people are going to end up in the other. And that should about equalize out. So some tall people should cancel out some short people. We should end up with groups that are about the same. So we might expect something that looks somewhat like this. Now the key here is that these are about the same, but there might still be some level of difference. And so after I've given my groups the treatment, if I see a difference at that point, I want to know, was that difference just because of randomness? Did I happen to put a few more tall people in one of the groups versus the other? Or was that difference caused by my treatment? And hopefully you can see some things like if the difference were larger, like if this were up here, if this were larger, then we would probably have more confidence that that was not simply the result of chance. More confidence, a larger difference, we would have more confidence that that's due to our treatment, and a smaller difference, I mean, all other things being equal, a smaller difference we would say is more likely just the result of chance. But we don't want to just sort of eyeball it and say, oh, that kind of looks small to me. We can actually calculate this mathematically. We're not going to do that here, but I just want you to get the idea that we can calculate this mathematically. We can calculate whether a difference is probably due to chance or probably not due to chance. And that is the idea of statistical significance. If we say something is statistically significant, we mean simply that the results are probably not due to chance. And so far we've talked about this just in the context of comparing two groups of people and saying, is a difference large enough to be a statistically significant difference? But this could be something we look at in anywhere where we're getting some kind of results where chance has an influence. If we were looking at a correlation, for example, if we were giving people, let's say that we're giving children vitamin D, or we're just measuring the amount of vitamin D that children are getting, and we're measuring their height. And we have some reason to think that there's a relationship between vitamin D and height, some kind of a linear relationship like this, and we're collecting data to see if that's true. But even if this is true, we still wouldn't expect all of the data to fall exactly along this line, because there's going to be other things that are influencing height. There are going to be a lot of factors other than vitamin D influencing height. So we wouldn't expect someone who takes a lot of vitamin D to be the tallest person around, but we might expect, if there's some relationship, that there's some consistency in the pattern, so that maybe the dots are not perfectly on the line, but maybe they fall close to the line most of the time, and we see some kind of a pattern. Now, again, the question is, if we were to just randomly throw dots on this scatter plot and there was no relationship between vitamin D and height, what are the chances of getting a particular result? And we can actually calculate that. And then we can say, okay, the result we got is that likely due to chance. This is very much like if you just take a coin and you flip a coin 5 times and you're asking, what are the chances of getting 5 heads in a row? Well, it's possible, but it's not particularly likely. So if we see a pattern in our results, like these dots falling very close to this line, we can say it's not likely that that is due to chance. In other words, we would say that is a statistically significant result. The results are probably not due to chance, so we would say it's statistically significant. And that's all that the term statistical significance means. Conversely, if we had dots just all over the place, then we would say this is actually quite possible that we get this kind of a pattern due to chance, and we can calculate that mathematically and say there's no particular reason to think that our results are anything other than just the influence of random noise. And again, we can calculate a concrete number for this. So we could say something like, for a given result, that there is a 95% probability that that result is not due to chance, or a 99% probability that that result is not due to chance. And I'll mention why I'm using those particular numbers in a minute. When you actually see this in a research report, this is talked about in sort of we look at it from the flip side. So instead of talking about a 95% probability that the results are not due to chance, we might talk about a 5% probability or a 1% probability. In this case, this is the flip side. This is the probability that the results are due to chance. Now, when you see these reported in a journal article, and rather than reporting it as percentages like these, we would usually see this reported as a decimal. So 5% as a decimal would be 0.05. 1% would be 0.01. It's exactly the same thing as saying a 1% or a 5% chance. And these are, just to give you some terminology you'll see used, these are called P-values. P-values is just a way of saying the probability of something being due to chance. So you'll see a result reported, like they'll say something like, we observed a difference between these two groups, and then they'll give you the p-value for that to tell you whether it was statistically significant. So they might say something like p equals 0.02 or p equals 0.34. Now, sometimes they'll give you the specific value like this. Sometimes they'll just say p is less than 0.05. What they're saying here is the probability that the results were due to chance is less than 5%. In this case, they would say probability is greater than 5%. In other words, there's a good chance or a good probability that those results are due to chance. So this right here would be statistically significant. This would not. And there's not this is a usual 0.05, a 5% chance or a 1% chance, sometimes a 1 in 1,000 chance. Those are the usual places that a scientist, in general, when we write articles, we say that's where we're going to make that cutoff point. That's where we're going to say we want to be at least 95% confident in these results not being due to chance before we place any real weight in them. And so that is why we say 0.05 or 0.01, but there's nothing magical about those particular numbers. That's just the convention. That's where we've said we'd like to be 95 or 99% confident that these things are not just due to chance. Now, there is one more piece of terminology that I want you to make sure you have tucked away in your brain, and that is something called the null hypothesis. So with our examples that we were talking about originally, for example, over here, we might have had a hypothesis like vitamin D is related to height. There's a relationship between vitamin D and height, in this case, a positive linear correlation. The null hypothesis is the opposite of that. Instead of saying there is a relationship, the null hypothesis turns that around and says there is no relationship. So in this case, the null hypothesis would be there is no relationship between vitamin D and height. Now, we can relate this to our p-values, to our probability. What we're saying is that if we find statistically significant results, that means that the pattern we're finding is probably not due to chance. So if this p-value here is what we had found for this graph, in which case we would be in a position where the points would all be clustered in a pattern that we were expecting to see rather than scattered all over the place like we have them here. But in that case, if we have this p-value that says this pattern is probably not due to chance, then it is probably due to some kind of relationship. So under those conditions, we would say that we can reject this null hypothesis. Now, if the p-value is higher, so that we're not so confident, then maybe the result we're seeing really is just due to chance. Maybe there's a lot of just random noise in here, and we're not so confident that we are getting a real pattern based on some kind of underlying relationship. It's hard to say for sure. In that case, we would say that we fail. There's a particular way we say that we fail to reject the null hypothesis. The reason why we put it that way, we don't say that we have supported the null hypothesis or proven the null hypothesis, because we haven't proven that there's no relationship. It could be that there's a relationship and we just didn't detect it. Maybe there's just too much noise here to have confidence that the relationship is present, but that doesn't mean there isn't a relationship. Vitamin D could be related to height, but if a lot of other things influence height as well as vitamin D, then we might not really be able to see that relationship very clearly. So that's the overall concept underlying statistical significance, and also some of the terminology that goes along with it. So hopefully now you can make a sense of some of these things, like when you see a p-value in the results section of a journal article, this is the kind of thing that they're talking about.